Okay, so I'm trying this out just because we may not have time to do study groups and such because all of us have different or separate exams and courses, and I am only able to meet with everyone on Thursday. Otherwise, good luck everyone, and I think on Thursday it's better if we do problems together. So I'm gonna go over some problems right now that if you study them before we meet on Thursday, you should be fine. I prepared probability questions, complementation, mapping linked genes, and lac operons. They're all from the homework and optional questions, and we're going to solve them together and see how they work. If you guys remember this question, we practiced it before exam 2. I just realized that we practiced it incorrectly, and I apologize for that. So we're going to do it again together. So when you read this question, it gives you the following three traits or diseases. One of them is color blindness, and that one is X-linked. So these are the conventions I'm going to use. So this is for colorblind. Oops. And if you guys know already, most of them you do, I'm bad at spelling. And this is for wild type or normal, as in no colorblind. And then for sickle cell, capital S, small s, this would be wild type or normal. And this will be for sickle cell since it's recessive, so it's a lowercase. And then myotonic dystrophy, it's dominant, so the capital M stands for myotonic dystrophy. Get the point. I think I misspelled it. And small m is for wild type or normal again. Okay, so let's read the question together. So they're saying that you have a couple that would like to have children. So couple, that means husband and wife. And then they tell you that the wife does not have any of the above diseases. Okay, that makes it simple. So she does not have color blindness, but she could be a carrier, so I'm not sure about the other X. She does not have sickle cell anemia, but she could be a carrier. And she doesn't have myotonic dystrophy, and since it's dominant, I'm sure of her genotype for that disease. Then they tell you her maternal grandfather, so let's draw this, mother, father, oops, let me do this again. So father, that's her mother, and then that's her grandfather and grandmother. So the grandfather has color blindness. Obviously the grandmother doesn't. The mother is a carrier for color blindness. Okay, we'll come back to this later. It's a very important piece of information. And then they tell you that her mother has sickle cell anemia. So if her mother has her mother, not her. What did I just do? Her mother has sickle cell anemia, so SS. That means that she definitely carries one of those genes. And then and she has myotonic dystrophy. Okay. Capital M. Guess in small m because she gave the small one to her daughter. Anyways, this piece of information about the mother does not affect the daughter in any way. Then now we go to the husband. The husband has normal vision, so he's XY. What else they tell us about the husband? Suffer from myotonic dystrophy, so we know he has a capital M here. Not sure about whether he has a small m or a capital M. For this one, he could be carrier for the normal gene, allele, sorry. His father and sister have sickle cell, so he has a sister. Father, mother. So the father has sickle cell, the sister has sickle cell. He doesn't have sickle cell, but he is a carrier for it. And then and I knew that from this information because obviously he will get the normal S from mom, right? And mom is a carrier. That's the only way the sister will get both lowercase s's, one from mom, one from dad, which means that mom gave him the capital S and dad gave him the small s. So I'm sure of how that looks like. And he and his mother do not. Sorry. Yeah, I read that part, but I didn't say it out loud. Okay, so far, this is what I know. The only two that I'm not sure of is whether the mother is a carrier or normal for sickle cell, and whether he's a carrier for wild type or whether he's carrier for wild type, because most probably one of his parents keep him myotonic dystrophy, but it could be both of them. So I'm not sure about that. Okay, so let's tackle part A. Part A. What is the probability that the couple will have a child who has none of the diseases? Okay, so let's do colorblind for both. Let's say whether the child does not have color blindness trait or sickle cell or myotonic dystrophy. Okay, so here, the probability that the mother is a carrier depends on this one. We know that her father is normal, because if he had it, that would have been mentioned in the question. So the probability, let's look at the mother. It's her mother, sorry. That's from dad. So it's 1-to-1. So the probability that she has, the probability that she is XX is 1/2, and the probability that she is a carrier is also 1/2. So, and then she mates with this guy who does not have the disease. So if we cross them together, so here the probability of the children not having anything is 1, but if she was a carrier, let's do this again. Probability that none of the children will have it, one of them would be a carrier but not exhibit it, is 3/4. Okay, and we said the probability that she's either XX or XC is 1/2. So here it's time 1/2, and here it's time 1/2. Probability that she has sickle cell is the following. Not her. The child not having sickle cell. So the mother is heterozygous for it, the father is heterozygous for it. See here and here, het and het. It's the phenotypic ratio is 3-to-1, and then probability of none of the kids having it is 3/4. Okay. As for myotonic dystrophy, we know that the mother is homozygote for the normal gene. The father could either be homozygote or heterozygote. If the father is homozygote, then all of the kids will have it, so 0 probability of having a non-affected child, so that's not going to factor into our probability. But if the father is heterozygote, then the probability is 1/2. Perfect. So if I was to do the probability of the kid not having color blindness, sickle cell, and myotonic dystrophy, first I'm gonna take the 1 times 1/2, right, times 3/4 for sickle cell, times 1/2 for myotonic dystrophy, plus the other probability, which is 3/4 times 1/2, times again 3/4 for sickle cell, times 1/2 for myotonic dystrophy. The answer is gonna be 3/16 plus 9/64. If you guys were to use a calculator or to do the math manually, that would be, multiply this by 4, so it's 12 plus 9/64. The answer is 21/64. Okay, so we now know how we got the answer for this one. Probability of the child not having any of the diseases is 21/64. Part B asks you what's the probability that the child would be colorblind but not have the other diseases. So again, we know for sickle cell not having it will be 3/4. For not having myotonic dystrophy, will be 1/2. And then for the child to have the disease, it's gonna be 1/4 times 1/2. So part B, and the 1/2 is because the probability of the mother being a carrier for it, hence giving one of the children the disease, in this case a boy. So the probability of having color blindness is 1/4 times 1/2, times not having sickle cell is 1/4, times not having myotonic dystrophy is 1/2. So the answer is 3/64. And that's how you solve probability using pedigrees. Trying to pause this. Where is it?